A ladder 10 feet long, leaning against a vertical wall, makes an angle of 65 degrees with the ground. Letter A. How high on the wall does the ladder reach? Express your answer in meters. Letter B. How far in inches is the foot of the ladder from the wall? Letter C. What angle does the ladder make with the wall? So for us to easier understand the problem, let us first make an illustration. Let us first know the given through an illustration. So the given. So a ladder 10 feet long, leaning against a vertical wall. Let's say this is the wall, and a 10 feet long. Let's say this is the ladder, 10 feet. So let's say that this is a 10 feet ladder. And it makes an angle of 65 degrees with the ground. So this is 65 degrees. So how high on the wall does the ladder reach? So for letter A, are required to get the height on the wall. Let's say this is y. The height the ladder reach on the wall. Then letter B, this is letter A. Letter B, how far in inches? So this is in meters. In inches, how far in inches is the foot of the ladder from the wall? So let's say this is x. How far, the distance of the foot of the ladder to the wall. And letter C, what angle does the ladder make with the wall? Let's say this is angle theta. So this is the what being asked for letter C, and this is what is asked on letter A, y, and this is what is asked on letter B, this distance. So we need to find for y, x, and this angle theta. The angle that the ladder makes with the wall. So those are the required. How about the solution? Let us solve this problem. So to get y, the height the ladder reach on the wall, we need to consider this angle 65 degrees and the length of the ladder. So if you try to notice, the wall, the ground, and the ladder creates a right triangle. X and Y are the legs, the sides, and the ladder is the hypotenuse, the longest side on a right triangle. Now, if we will be reminded of our trigonometry, we can just simply solve this problem by using a trigonometric function. Now, what is the function that we have to use? So we need to use our SOHCAHTOA, the sine, cosine, tangent function. So like for question A, we are being asked to find y, the height of the ladder, reaches the wall. Then what do you think is the most appropriate function that we have to use? So we need to involve this angle 65 degrees. Your y is the opposite side, and the 10-feet ladder is the hypotenuse. So the most strategic function that we need to use, that we have to use, is sine function. Let's say sine 65 degrees, sine is opposite over hypotenuse. The opposite of 65 degrees is side y, and the hypotenuse is the ladder, which is 10 feet. For us to get y by cross multiplication, therefore y is equal to 10 feet times sine 65 degrees. Y therefore is, so if we are to compute for y, 10 times sine 65 degrees, the answer would be 9.06 feet. 9.06 feet. But we are being asked to find the answer in meters. So how do we now convert this feet to meters? Let us use a conversion factor. From our conversion factor, 1 meter is approximately 3.28 feet. Now let us use this common conversion factor to get y in meters. Now, to convert this, we'll just have to 9.6 feet multiplied by 1 meter. For every 1 meter, there is 3.28 feet. So that feet will be cancelled. The remaining unit will be meters. So 9.06. So our answer, 9.06 meters multiplied by our conversion factor, that for every 1 meter is equal to 3.28 feet. So the answer would be 2.76 meters. So y is equal to 2.76 meters. This is our answer for letter A. How about for letter B? For letter B, how far in inches is the foot of the ladder from the wall? So we're being asked to get the x, the horizontal distance. To get the horizontal distance, again, we need to think of the most strategic trigonometric function that we can use. So the x side is the adjacent side, while again 10 feet is being given. So from our trigonometric function, the most strategic function that we can use is the cosine function. So cosine 65 degrees is equal to the adjacent side, which is x, all over the hypotenuse. The hypotenuse is also 10 feet. The length of the ladder. Again, by cross multiplication, we'll have x be equal to 10 feet times cosine 65 degrees. So x would be equal to 10 feet times cosine 65 degrees. The answer would be 4.22 or 23 feet, because it is 4.226 or approximately 4.23 feet. This is the horizontal distance. Okay, but we are being asked to find this length in inches. How far in inches is the foot? So we all know that 1 foot is equal to 12 inches. So again, we just have to convert 4.23 feet multiplied by our conversion factor. So 12 inches is to 1 foot. Again, we need to put the unit feet under as a denominator, so that it can be cancelled and the remaining unit will be in inches. So let us now solve for x, 4.23. So that is 4.22.6. Let's just continue it in our calculator, multiplied by our conversion factor. 12 over 1 is 12. So let's just multiply this by 12. We can now get the answer. So that is approximately 50.714 or 50.71. 50.71 inches. Okay, how about for letter C? For letter C, we are being asked to find this angle, theta. We are being asked to find this angle, theta. Now, we can now easily get theta because we now know the sides, the three sides. We have x side being equal to 50.71 inches. On y is 2.76 meters. Now we need to get the angle, but for us to get the angle, the side should be with the same units. So like for example, we can just easily get the angle by subtracting 65 degrees from 90, because from a triangle, the angle sum theorem for a triangle, the sum of all the angles inside the triangle is equal to 180 degrees. But if this is a 90-degree angle, if this is a 90-degree angle, 90, therefore the remaining two angles, the sum of the remaining two angles is 90 degrees. So 90 degrees is equal to 65 degrees plus our angle theta. Therefore, theta is equal to 90 degrees minus 65 degrees, which is equal to 25 degrees. This is our theta. Let us just try to make sure that it is indeed 25 degrees. Can we use the trigonometric function to confirm that it is indeed 25 degrees? Yes, of course, we can. So let us try to check if it is indeed 25 degrees. Let us try to use what function do you think? Okay, let's try if a function, sine function, for example, or tangent function, so that we can make use of our x and y. Because if we will use tangent, tangent is opposite over adjacent, so the opposite side would be x, and the adjacent side would be y. So let us try to make let us try to use tangent function. Tangent is opposite tangent theta. Tangent theta is equal to opposite, which is x over y. Therefore, theta is equal to arc tangent x over y. But we have to make sure that x and y have the same units. So like for example, our x is 4.23 feet and our y is 9.06 feet. So that is both in feet. So that's what we have to use. Let us now solve for the angle. So theta now is arc tangent x, which is 4.23 feet. We can disregard now the unit. It will just be cancelled. It's the same, over 9.06. Okay, so let us try to compute for this angle. Arc tangent shift in your calculator, shift tan arc tangent 4.23 over 9.06 equals. So the answer is 25.027, almost equal to our first answer when we use the angle sum theorem. So theta would be 25.03 degrees. So there are just a little bit of discrepancy because we have rounded off our previous answer for x and y, but these two is almost equal. Okay, so that's how we can confirm for the answer. So now our answers for letter A, the height of the ladder reached the wall 2.76 meters because we are asked to have it in meters. X, the distance of the foot of the ladder to the wall is 50.71 inches because we are asked to have it in inches. And the angle that the ladder makes with the wall is equal to 25 degrees. So that's how we solve for this problem.